Question number 4 says 2 points M and N are given by their latitudes and longitudes as M 50 degrees south, that is the latitude, 15 degrees east, that is the longitude. Then N 50 degrees south, that is the latitude, the same latitude with M, and 75 degrees east, longitude. That means both N and M are on the same side of the globe. They were asked to calculate the radius of the latitude of M and N. B, the distance of M and N measured along their latitude. Let's have our sketch. That is the first thing in solving a question on longitude and latitude. Draw your pole, connection of the north and south. This is your east, this is your west. Draw your equator. The only line of latitude that is the same thing with the circle of the globe. All right. Let's assume that this is the center of the latitude. Doesn't look like the center. Let center be here. Yeah, this one is better. 2 points M and N are given by their latitudes and longitude as M 50 degrees south. So draw a line of latitude on the northern part of your globe. Let this represent 50 degrees north and 15 degrees east. Let this represent 15 degrees east. You can see that I draw the first line of longitude very close to the pole because I have seen that the other line of longitude is greater. I have given a space to accommodate the next one I'm going to draw. That is the senses behind this kind of a thing. So this line of longitude is 15 degrees east. So this place now should be the point M. So let's represent it with M. Then the next one is the same 50 degrees south. Sorry, this is not on the south. It should be on the, or let's change this instead of going to withdraw. The mistake I made now is that instead of drawing this line of longitude on the south side, I was drawing it on the north side. But because of the constructions we have made already, let's change these things to north. We still get the same answer. So that you can continue from the diagrams we have drawn already. Sorry for that. Okay. So 50 degrees north, but 75 degrees east. So this next point N should be something like this. This place now is 75 degrees, the same east. So this point here, the point of intersection of the line of longitude with the line of latitude, is now going to give us our N. Okay, now the first question says we should calculate the radius of the latitude of M and N. The radius of this latitude. Remember, these 2 points M and N must have made this angle to the center of their circle of latitude. So they have made this angle here. and there's a connection of both of them to the center of the arc. So this is the small r now, and this is the big R. Now I told you this is a right angle triangle, and this angle here is 50 degrees. So if you bring out this triangle now, you are going to have something like this. We have started answering question number A. We're going to have a right angle triangle in this form, where this place is the right angle. This place is 50 degrees. This is small r, and the hypotenuse is the big R. Now, the question is asking for small r. It is the small r that is the radius of the latitude of M and N. Remember, our cosine theta will give us adjacent over hypotenuse. Adjacent over hypotenuse. And the adjacent to this angle is R, all over hypotenuse, which is big R. That means our cosine, and this our theta is 50 degrees. If you cross multiply, discover that the small r equation asking for is going to be big R times cosine 50 degrees. This big R, the value of big R, I'm sorry, I don't know why I'm omitting this. Assume R is equal to 6,400 kilometers. That should be part of the question. Now, our small r is now going to be big R, which is 6,400 times, let's find cosine 50, giving us 0.6420. Sorry, 6428 in 4 decimal places. So if you multiply out, you find the value of your R. It's giving me 4,113.92 kilometers. That is the value of the radius of the circle of latitude where M and N is found. Find the distance of M and N measured along their latitudes. We are going to clean up question number A because we don't have enough space to do question number B. When we clean up this, we will now do question number B. It's asking for the distance of M and N measured along their latitudes. It's simply asking for the length of arc MN. And arc length, let's represent arc length by AL. Is calculated everywhere in the world, including in your local government, by this formula, theta over 360 times 2 pi. Remember, we are working on a line of latitude. The R that we are going to use here is the small r, which has the value of big R cosine theta. So we have big R cosine theta. Now pay attention. This theta, the theta you are going to substitute here, is not the same thing as theta you are going to substitute here. The theta you substitute here is the angle, the 2 points, or the arc subtend to the center of the circle, which you get from the difference in the lines of longitude where the 2 points lies. This other theta of 2 pi big R cos theta is the line of latitude where you are walking on. They are not the same thing. The first theta, the difference in the lines of longitude. Second theta, the line of latitude where you are walking on. Now, we are going to have our theta here now is going to be 75 minus 15. All over 360 times 2 pi r cosine 50 degrees, the angle of the latitude where you are walking on. All over 1. I want to bring this equal to here because of space of what I want to write here. 75 minus 15 will give you 60. Divided by 360 times 2 all over 1 times pi 22 all over 7 times r 6,400 all over 1 times, let's know the value of cosine 50. Given me 0.6428. Camera is warning me because of space. I hope it still took this. So this I have rounded up to 4 decimal places, 64278. It's now giving me 6428. So let's multiply out. We now have 120 2 times 60 times 22 times, let's multiply this and this, giving me 4,113.92. Then all over, remember, 360 times 7 is 2520. I told you to memorize this. You will always be meeting it. So that you won't be wasting your time pressing the calculator or doing any other thing. So let's multiply the numerators. 4113.92. It's given me, let's divide out immediately. Divided by 2520. 4,309.82 kilometers. So that is the value of that arc where M and N is found on the circle of latitude 50 degrees north. Q R 50 degrees south, 32 degrees west for P, and 50 degrees south, 48 degrees east for Q. That is the meaning of respectively. The first is for P, the second is for Q. They were asked to calculate based on that information. A, the radius of the circle of latitude of P and Q. B, the distance PQ measured along their latitude. C, the speed due to the rotation of the earth of the point P if the earth completes a revolution in 24 hours. Assume that R is 6,400 kilometers. I want you to pay accurate attention on question number C because that is the essence of this question. We have known how to calculate A and B in our previous questions. The first thing we do is we represent our globe in a simple diagram. Draw a pole that joins the north and the south. This is your east and this should be your west. draw your equator, 0° latitude, and indicate its center. You have started. Now go back to the question. The 2 point P, 50 degrees south. This is the southern part of the globe. So draw any latitude on the southern part to represent 50 degrees south. So here is 50 degrees south and 32 degrees west. So draw a line of longitude to represent 32 degrees west. So name it 32 degrees. Is on the west. So the first point, which is P, should be here. The second one, which is Q, is 50 degrees south, the same line of latitude, 50 degrees south, but 48 degrees east. So write or draw its line of longitude on the eastern part of your globe and name it 48 degrees east. So write 48 degrees is already in the eastern side. So this point of intersection, sorry, no, P was not here. It's not on the equator. It's on the line of longitude 50 degrees south, please. Sorry. So this is P, and here the point of intersection of the line of longitude and latitude. Here will be Q. So this place and this place is not for P and Q, it's here and here. Okay. Now we have represented the 2 points. Now the question says A, calculate the radius of the circle of latitude of P and Q. A. These 2 points must have made this angle to the center of their circle of latitude, and they have this connection to the center of the earth, where this place is theta. This place is the right angle side of the triangle. This is R, the radius of the earth, and this is small r, the radius of the circle of latitude 50 degrees. Now, this theta here is 50 degrees, the angle of the line of latitude. Now, if you call here theta, which has a value 50, you discover that cosine theta will be adjacent of a hypotenuse, which is r all over, sorry, small r all over big R. So we now have that cosine 50 degrees is equal to our small arrow, which is the adjacent, all over our big arrow, which is the hypotenuse. Arrow times 1 will give you r. Is now equal to big arrow times cosine 50. Remember, the question says we should use 6,400 for big R. That means we now have, instead of big R, 6,400 now times whatever cosine 50 is. 0.6428 in 4 decimal places. If we multiply out, whatever value we have is the value of our small r. It's giving us 4,113.92 kilometers. That's the value of our r. That's our small r. Question number B. Let's see if this space will be enough for question number B. Says we should calculate the distance PQ measured along their latitude. Distance PQ. This PQ sustains an angle here. And this angle they sustain here is not the angle of the latitude, but the angle you get by adding the line of longitude of Q and the line of longitude of P, because they are in different directions, in different positions. This one is on the east, this one is on the west. So you add the value of the lines of longitude where they fall together to get the angle they subtend to the center of that line of their latitude. So now, what you're looking for here now is arc length, AL. And arc length is calculated by theta over 360 times 2 pi big R cosine theta. Big R cosine theta is a substitute to small r because we are working on finding arc length of a circle of latitude that is not the equator. Alright, so this divided by 1. Let's fix the values we have. Let me also use or seize this opportunity to tell you the difference between this theta and the second theta. This theta is the angle the 2 points subtends to the center of their line of latitude, and you get it by adding the line of longitude on this side and the line of longitude on the other side. Whereas the second theta is the angle of the latitude where you are working on. In my experience, I discovered that almost all the students, in most cases, we make the mistake of not fixing the correct theta in these two variables. Please get it into your brain. The theta you are dividing 360 from is the angle, the 2 points that form the arc subtends to the center of their circle of latitude or their circle of longitude, depending on how it comes. The next one is the theta of the line of latitude where the 2 points are found. Okay, so our first theta will be gotten from 48 plus 32, which will give you 80. We are adding the two lines of longitude together because they are on different directions. This one is on the east, this one is on the west. So let's bring our equal to here, AL, arc length, because of space. The theta is 80. That means 48 plus 32. The lines of longitude of the 2 points P and Q. Now divided by the 360 times 2 all over 1 times 22 all over 7, that is pi, times our R, 6,400. So we have 6,400 all over 1 times cosine 50, the angle of the latitude where P and Q lies. So let's find the value of cosine 50 straight because of our time and space. And 50 is having the value of 0. The camera is giving signal 428. Okay, let me just believe that the camera got it. Okay, so what we have here now is 80, 48 plus 32 divided by 360 times 2 times 22 is 44 divided by 7. times, let's multiply this and this. It's given me 4,113.92 all over 1. The last stage. Let's multiply the numerator together and the denominators together. 80 times 44 times 4113.92 is giving us this value divided by, I have always told you, memorize 360 times 7 because you will keep seeing it. The value is 2520. So if we divide what we get by multiplying the numerator together by 2520, the value of 360 times 7 times 1, to give you, we have 5,746.43 kilometers. So this is the distance of the arc PQ, which is the same thing as the distance of PQ measured along their latitude. We are going to clean this question A and B so that we can do question C. Remember, I told you the caption of this question is because of question C. How to calculate the speed about a particular point on the globe based on what it takes for a complete revolution to be made. Let's do question number C. Question number C said we should calculate the speed due to the rotation of the earth of the point P if the earth completes a revolution in 24 hours. They can tell you the speed due to the rotation of the earth of a point P or Q. They can also say due to the rotation of the earth of a point on the latitude of P or the latitude of Q. They can say of a point on the latitude of 50 degrees north. So whichever way it comes,